David. So my name is Jen Stirrup, and in this session today, we're going to look at business intelligence and artificial intelligence, the importance of data for business leaders. So in this session, we're going to look at business intelligence and how we can make the data meaningful for the data journey. What we want to do is have a think about how we can make it meaningful for business leaders. What types of data are there? And what frameworks can we use to help us to understand data in an end-to-end manner? We'll also have a look at the parts that the business does not see, such as the plumbing of the data, and we want to make it relevant for the data for the business as well. We'll also look at big data frameworks, and we'll also look at data visualization as well. Because put together, knowing this information will help you to select the proper visualization, will help you to best convey the meaning and the relevance and the power of the data to the business. So my name is Jen Stirrup. You can see my details there if you'd like to get in touch. I'm also happy to accept LinkedIn invitations if you'd like to keep in touch after the session. So what's the state of business intelligence in AI in businesses at the moment? According to a recent survey, the average adoption rate of business intelligence among employees in mid to large companies is only 15%. So this means that roughly 1 in 10 people at companies using business intelligence platforms are using the solution for day-to-day work. Now that's not very much. Given the importance of data, why don't we see much greater adoption rates than only 15%? We know there's an explosion of data sources. For example, there are some estimates which show that there are 1.6 trillion data dividend for businesses that take advantage of the data explosion. You can see here, data is coming from a lot of different verticals. And ourselves, as individuals, we produce lots of data every single day. Every time we send an email, or we swipe in and out of our buildings, or we send a text message or a WhatsApp, we are data producers. But despite this flood of information, it's really hard to make all of this machine scale data down to human scale. It has to be made much more simple in order for people to really understand the data. Otherwise, how can we understand all those billions of data points that all of these systems are producing? So we have a tough problem when we deal with data for the business. We have so much data, but it's not just about big data. It's about the right data. What data should we be looking at? Because after all, if we don't have the right data, then we may not be able to make the right business decisions. As we see here, genius depends on the data within its reach. In many businesses today, we have this situation where we are trying to work out the landscape of the data within the business. So what you see in the bottom left-hand side here is a data aristocracy. In that situation, companies don't always find it very easy to get hold of the data that they need. The data is reserved for the aristocracy. It's only for the business leaders. That makes it harder for other people to do their job very well. We also have the situation of data anarchy. In this situation, we probably see lots of Excel spreadsheets everywhere, uncontrolled, unmonitored, and unloved. Are they being backed up? or are they simply being held in people's inboxes? We've also got the data dictatorship. In that example, only the business leaders are able, in that example, only the data leaders are able to get at the data and they don't let anyone else see it. That usually indicates a problem. What we'd like to see in companies is what we call a data democracy. And what I mean by that is people have access to self-service business intelligence and they are able to get a hold of the data that they would like to see. So with a data democracy, the IT teams are able to perform their guardian role of the data. They're able to secure it, they're able to back it up and restore it when required. In that happy place, the business teams also have access to the data that they need. They're not always building little empires of Excel spreadsheets everywhere. So the situation we want is where we are aiming for that data democracy, which will drive infrastructure, architecture, and software choices. We talk a lot about the democratization of data, but we don't always make that possible for people, and that's something we have to implement for business. Democratizing data assumes that everybody has the same access, power, and control over the data as everyone else. But that's not always the case. In the industry, we also focus a lot on big data, but sometimes it's the small data that's running the organization. Sorry. We should be enabling people to use the data regardless of its size. And what about artificial intelligence? To have good artificial intelligence, we need to have good business intelligence first. If we don't have a good data source, then it's very much a case of garbage in, garbage out in business intelligence, but we will also have garbage in, garbage out when we look at artificial intelligence as well. And when we think about artificial intelligence, what we expect to see is technology which we don't notice. For example, artificial intelligence is becoming such a big part of our lives. It's not going away anytime soon. Beware of salespeople trying to tell you that artificial intelligence will solve all the problems. It's not true. But we do know that artificial intelligence is becoming a part of our everyday life. We see here a quote from the author Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic, and we see that when we deal with AI. It's in our smartphones, so we have a little piece of it with us every single day. But people are not always sure of what artificial intelligence actually is. So here we have three distinctions of artificial intelligence. We have artificial narrow intelligence, and that's the artificial intelligence that you see available to you when you start to use technology such as Alexa or using the voice technology on your mobile phone. These artificial narrow intelligence systems tend to be very good at one thing and one thing only. So Alexa is very good at telling me about my next Amazon order, but doesn't do much else apart from very short snippets of conversations. We also have artificial general intelligence, and that's hallmarked by having the ability to have general contextual information, knowledge, and use it correctly. Steve Wozniak is one of the co-founders of Apple, along with Steve Jobs. He invented the Wozniak test. Basically, can an artificial intelligence machine, a robot, come into your house and make you a coffee? That's harder than it sounds. The robot has to identify where your kitchen is. It has to identify the ingredients in amongst everything else in your house. And then it has to put the ingredients together to assemble a coffee for you. And then it has to do it in the right order, as you would like. So actually making a coffee requires a lot of contextual information, and that's not always easily available. So we also have ASI, Artificial Super Intelligence, and that's the belief that AI will take over and become better than humans in some way, and the situation will be reversed. So when people think about artificial intelligence, we have to ask them exactly which definition are they looking at. Sometimes people worry that artificial intelligence will put people out of a job. And that's one of the concerns of using artificial intelligence. What happens to people's creative skills? I think artificial intelligence will start to make our lives easier in many ways, but it will be a complement to human skills rather than a replacement. We can use artificial intelligence to automate solutions, and that's a great thing for businesses to do. We can do things that will make our lives easier. It's not necessarily a replacement for humans, it's just making our data easier to get normally. But when we are thinking about artificial intelligence and business intelligence, we have to ask ourselves exactly what is the objective? What is it we are going to try to do? Often we have to understand the vision of the business, and we have to understand what the business hopes to achieve. Normally, that's making more profit, but it could be things like cutting costs, for example. So that's where we have to understand what is it the business are trying to achieve. Are they trying to use technology to cut costs, to understand customers better? Perhaps competition is something they are trying to improve their competitive advantage. They may also want to become more creative by allowing technology to automate a lot of processes. So we have to think about what artificial intelligence will be used for. I'm going to focus on AI for cybersecurity. Cybersecurity is such a huge part of our everyday life, and we perhaps do not always realize it. So things are really going to get exciting using artificial intelligence in businesses. And here's some ways that we can start to think about using AI for security. You can see more organizations moving away from passwords and more towards using biometrics. We know that passwords have lulled consumers and customers and colleagues into a false sense of security. It becomes increasingly problematic as all of us spend more time in online environments. If we use biometric authentication, it could enhance the security for the business, and it can also enable frictionless and more convenient customer experiences as well. Hopefully, this will help to lead the way towards a more secure digital future. As colleagues and customers begin to understand security better and the simplicity considerations of biometrics, they'll become more comfortable with these platforms. For example, we may see more of this in the finance industry, which is starting to use voice data and use voice biometrics. And you can expect that this trend trend will spread beyond this sector and into other industries. We can also see that artificial intelligence can support business intelligence in the area of data crunching. AI and machine learning have become increasingly critical technologies in information security. They're able to analyze millions of events and do that very quickly, and they're able to search for different types of threats. This could be from malware exploiting zero-day vulnerabilities or identifying risky behavior in a business as well. Technologies can learn over time, and that means they can draw on past information to identify new types of attacks. So we can develop histories of behavior using the data to build profiles of assets, users, and networks. This allows artificial intelligence to detect and respond to deviations from what we expect to see. But to do all of this, data engineering is such an important part of what we do. Since we spend so much of our times online, this means there is a vast attack surface. There are tens, hundreds, or potentially even thousands of devices per organizations. There's also a huge shortfall in the number of skilled security professionals because we have got masses of data. So we're moving beyond that human scale problem to having a machine scale problem. And that's where business intelligence and artificial intelligence are very useful for businesses. It can allow us to move from human scale data to machine scale data. AI will make the most of our human skills. We can have some of our skills are replicated quite easily, relatively, like analyzing handwriting is something that you can identify text recognition, and it's not always perfect, but the thing is, it's sometimes hard to read people's handwriting anyway as humans, so we can't always expect machines to do something very well that we don't do very well ourselves. I'm personally not a very neat handwriter, so you might find it hard to read my handwriting. So hopefully all of this technology and all of this data is going to help automate processes and make more of our human skills. Because there are implications to using artificial intelligence in businesses, but we have to accept that they are here to stay. With the rise in connected enterprises, businesses are becoming increasingly vulnerable as they're connected to a massive independent endpoints. Businesses are connecting to each other as well. So AI is great for proactive threats mitigation capabilities. It can help to supervise. But AI itself can also introduce vulnerabilities as well. Organizations will need to guard against the downside of this exciting new technology as well. It can help guard against cyber attacks. But hackers have been shown to be able to foil security algorithms by targeting the data that they train on. So we know when we use artificial intelligence and machine learning, we need a training data set, and we also have a test data set. But if a hacker erases or messes up your test and training data sets, that really impacts all of the AI system because the artificial intelligence system is based on data. And if hackers can impact and affect your training data set, they can actually impact your AI algorithms as well. So that's something to be very mindful of. Hackers can also use AI to break through defenses. They can develop mutating malware. Like they can change their structure to avoid detection, a bit like a virus. But if you don't detect that data manipulation, organizations can struggle to recover the correct data that feeds into artificial intelligence system. This could have disastrous consequences for your AI algorithm And that's why we need business intelligence in place first before we do artificial intelligence. It helps us to identify data engineering and data manipulation. We can look at our reports and our statistics and understand the data better. So there are a number of implications and threats. We know that remote work isn't going anywhere for some time. Security measures and fraud prevention solutions. We need to secure customer and employee interactions, and they need to operate in real time. So when many individuals will sit outside an organization's firewalls, that we can identify fraud attempts against remote workers. We know that during the pandemic, fraud attempts against remote workers and frontline agents have soared during the pandemic. We expect this will continue as long as employees are empowered to work from anywhere indefinitely. There's also privacy implications as well. Employees who are not supervised with access to personally identifiable information. They have new opportunities to defraud their employers and customers. But remember, this may happen inadvertently as well as deliberately, as employees do not always take care of data. So how can we onboard artificial intelligence successfully in our business? Organizations can layer in and leverage artificial intelligence in ways that can help us to protect, adapt, and prioritize our customers' experiences and customer services. For example, I mentioned biometrics earlier, which is a range of modalities for customer authentication, including voice, behavior, facial recognition, and so on. It makes things faster, simpler, and more secure than ever. But all of these technologies must be used with data privacy in mind. Artificial intelligence, and biometrics in particular, creates powerful platforms for solving quite difficult security problems. But to do this, we require a significant amount of data, which you must collect from your customers, and it all has to be guarded and protected because it's an invaluable resource. So therefore, good data governance is good business. If you want your customers to ditch their password in favour of biometrics, for example, they must trust you first of all to manage that personally identifiable private information with the utmost care and concern. That's more than simply alerting people to your privacy policy. You need transparency, informed user consent, as well as codes of conduct for any third parties that you work with. Because how you handle customer data is really all about how you handle your customer. Your data must be handled with the utmost integrity, and privacy protection design is vital at every layer of every customer interaction. This becomes increasingly difficult because there aren't enough AI and skilled cybersecurity professionals. But we need to retrain everybody so they understand the importance of data privacy and good data governance. You can expect this to grow in the market as well. So just a quick summary, how do we onboard successfully artificial intelligence for a business? And as a business leader, as potential business leaders now and in the future, you need to think carefully about your customer data and really put that front and foremost of your mind. Treat it with integrity and take care of it for your customers. You must always put people first in any business. We know that there are all sorts of state-sponsored attackers potentially trying to get at people's data. That's what they say in the news anyway, whether you believe that or not. Even if you don't believe that, we do know there are criminal cyber gangs. and also ideological hackers who can employ the same AI techniques to attack data as anyone else. So we need to be careful to set up good defences and avoid detection. So what kinds of data are there? There's many types as we have at a high level. We have big data, little data, and real-time data as well. There's a number of challenges for the modern data platform. First of all, there's a number of inefficiencies that we have when we start to deal with very fragmented architectures. So you can see here that there are different ways that we can conceptualize our data. We can store our data on premises or in the cloud, and then we need to think about relational databases such as SQL Server and how that relates to big data sources that do not fit that nice, neat relational format. So when we think about cloud data, we may be thinking of databases such as Oracle, for example, or Microsoft SQL Server. And we can also have cloud databases as well. We know there's a range of great databases from vendors such as Amazon, for example. And then we can think about what do we do with our on-premises big data sources? What happens there? How much investment do they need in terms of costs? And then we need to think about cloud data sources, which are beyond relational, who are now putting together big data sources. So here's the problem, and here's the thing. We have disparate systems and processes. If you see a data problem in a business, it's probably a business process problem, and that's often harder to deal with. You'll also find in businesses there are multiple tools and skill sets as well. Not everyone is data savvy. Not everyone is as passionate about data as I am. There's also siloed insights. If your data sources are siloed, then your analytics are siloed as well. And that's a problem when we start to deal with architectures. Do we bring the data together like a data fabric architecture? Or do we build a data lake where the data is all brought together in one data store? We also have to consider the high cost of ownership as well. We can find that using on-premise technology can be more expensive. So what is big data then? Well, it's unstructured and semi-structured data, and it's not always a substitute for a database. It can be a data store. It's not always relational. It may use key value pairs. I'm going to talk more about these terms. And it places no conditions on the structure of the data it can process. In a relational database, it imposes a structure on the data. The data is expected to be in rows and columns, like an Excel spreadsheet, and that's something you're probably very familiar seeing. But when we deal with unstructured data sources, it places no conditions on the structure of the data that's been processed. We also have a problem. How can we make big data human scale and comprehensible? How can we take this machine scale data and make it human scale? We know that people do not always understand data, and I put this in because it makes me laugh, and I hope it makes you laugh too. So we have a phrase here from Bill Clinton. Every American should earn above average income, and my administration is going to be sure they are going to get it. So if everybody earns above average income, what happens to the average then? It goes up. So as statistics show that teen pregnancy drops off significantly after the age of 25. Now we expect that because they're no longer teenagers. Stop being teenagers when they turn on their 20th birthday. You can also see in the right-hand side here, would you see that um, A-level, would you pay more for your milk to help dairy farmers? So you can see the pie chart looks as if it's 50-50, but when you look at the data, it actually shows 87%. So data is a funny thing. You can be significantly different but never certain. Deviation is normal, and you're amongst friends if you find these funny, because I do. But designing visualizations to help us understand the data, to communicate it clearly, doesn't have to be complicated. Big data is messy. When people want to see visualized data on reports, charts, and dashboards, there's a problem. Everybody wants to see their data in their way, and they want to see their data how they want to see it. They don't care about everyone else. We call this the chocolate cake problem. Everybody likes their cake in a different way. We also have the same problem with coffee. Everyone likes their coffee in a different way. I must admit I'm a huge fan of Chennai coffee. It really wakes me up. You may not like that, you may prefer something else. But everybody likes the data in the same way they like their coffee or their cake. Everyone has different tastes. So it becomes quite hard to try and find a solution that will suit everybody. We have messy data, and we're trying to please people who do not always know what they want and have very different opinions. Now, you may remember this, you may not. It's called the golden record problem. In the early 1980s, NASA sent a golden record into space. And this golden record was going to tell any alien force more about Earth and the human race. So businesses have a golden records problem. What data actually defines their customers? What data is the most important data that you would put on a golden record if you were to send that golden record into space? That's the problem that NASA had. What data really defines the human race? So we also in businesses have master data management solutions. They act as the single source of truth for any given entity in the enterprise. A master data management solution can act as a hub for multiple systems, many of which can be the source of truth for updates for different aspects of information on a given entity. It can receive updates from multiple sources. It can act as a broker to determine which updates are to be regarded as authoritative as the golden record. And then this can sync the data to all subscribing systems. Because in business, we have the bystander problem, where we don't pass bad data on to the next person, or we shouldn't, but in businesses, that's what happens a lot. The bystander effect is where we think someone else is going to solve the problem, but they don't. It becomes everybody's problem, but nobody's problem to solve. Bystanders are mostly users who are consumers of the data. So, at most, the best that they can do is to provide feedback that the data is not correct. Users sometimes don't feel motivated to tell you that the data is wrong, and they end up being bystanders. If organizations start to create an atmosphere or an environment where action is taken and feedback more quickly, then the data whistleblower can be thanked and rewarded. You get the behavior that you reward. And the number of bystanders will reduce as people start to own the data cleanliness. And we know that data cleanliness is so important for artificial intelligence and business intelligence. But people also have to understand the data as well. Effective visualizations help the stakeholders in the business to use that information for effective decision making. And that's why we care about data in the organization. When people look at data, they look at it for maybe 5 to 8 seconds, and then they decide whether or not they're going to look at it again. So you have to be very careful about how you design data visualizations. People have got very limited attention spans, and they're also very busy, and there's also lots of other data to look at. So you're designing these data visualizations to try and help the organization to make the right decisions. Here's some examples of data visualization. The London cholera map, 1854 in London. In over 10 days, 500 people are killed in one neighbourhood. It becomes a cluster of deaths, and people are scared. Everyone's scared, that is, apart from a gentleman called John Snow, who realised the water supply was spreading the disease. So John Snow mapped every single death on a map, using bar charts to show how many people died in certain areas. He was able to show that the London Broad Street water pump was infected, and that caused the greater number of deaths. That helps the public to understand that a true sewage system was crucial, and that helps London to have the sewage system that it has in place today. If you've never looked at the Gapminder video with Hans Rosling, I recommend that you do. He very sadly passed away recently. It's a great loss to the world of data visualization. He showed the relationship between income and life expectancy. Rosling's visual storytelling for data is amazing, and if you can, look at his YouTube videos. I recommend that you do. We also see Florence Nightingale, who used data in order to help identify and explain the reasons for soldiers dying in the Crimea War. So we can see that the number of deaths here was shown by the story of the data. And she showed the number of deaths due to preventable diseases. And that helped the British Army to understand that sanitation was really crucial. And that's why we see so much sanitation in hospitals today. To do that, you have to consider the kind of data story that you have. What is it you're trying to find? Is it distribution? A part to a whole? Are you trying to find correlations? Or simply just a ranking? So what's happening in the future? We're just going to see more and more data. Data is not going away, so we have to think of ways that we can use our data so it becomes increasingly important to businesses. They can understand it better. So where did big data come from? Well, in the 1980s, we had the application sitting on one database. We know that architecture doesn't scale very well. So in the 1990s, we see the database as an integration hub. The application is still sitting in one database, however. In the 1990s, we start to see decoupled services. We see the application and the database being scaled out. But let's have a look at some big data and NoSQL concepts so you can see the problem that businesses are going to have in the future. Prior to NoSQL, we had databases in relational format and also in OLAP cubed format as well. But then there was a tipping point where we had to start to think about NoSQL. You can see the pressure residing on databases. So you can see that we had started to see large data sets. We needed a solution for scalability, and we also had to think about this differing structure of data as well. We also saw the advent of social media, where everyone started to share cat videos. So what we had to think about was NoSQL, which is basically not only SQL. It doesn't mean it's not using SQL. They can use SQL as well. NoSQL data sources are used in popular technologies that you probably use every single day. For example, Cassandra is used by Facebook, Twitter, Reddit. Cisco use it as well. Hadoop is another technology like a big data attic, and it's used by Amazon, Pentaho use it, Yahoo and the New York Times. CouchDB is used in places like the BBC and also CERN. Mongo is used by Foursquare and Bitly. And React is used in Widescripts and Western Comms. So different types of data need different types of solutions. What we see here is data split into structured, semi-structured and unstructured sources. We could have transactional data sources, relational and data warehouse data stores, and we can also think about how documents are stored as well, such as XML or JSON format. So we start to see new data sources starting to appear. Document stores are great for agile development, where we have a hierarchy of objects clustered together in logical groupings. Before the advent of NoSQL, selecting a database was more about selecting the vendor and selecting the shape of the database. Microsoft Office, such as Excel or Access, were also options. So let's go through some of these more big data sources. We have got relational data stores. Their tabular formats are very well understood, and it's a very mature technology widely used in the industry. We've also got SQL concepts, and they tend to have good security. We've also got the SQL language we can use as well. People are very familiar with it. However, a problem is that we have to do very strict data modeling on relational databases. Relational is built for business teams. They understand the data in terms of how it's described, which are the dimensions, and the facts, which are the metrics. We've also got fast reads as well, and we can also look at historical data as well. We've also got key value stores. A key value store is a big data storage paradigm. It's designed for storing, retrieving, and managing associative arrays. It's also known as a dictionary or a hash. Dictionaries contain a collection of objects or records, which in turn have many fields within them, each of those containing data. The records are stored and retrieved using a key that uniquely identifies the record, and it's used to quickly find the data within the database. Since optional values are not represented by placeholders as they are in most relational databases, key value stores often use less memory to store the same data, and that can lead to large performance gains when we use it with certain workloads. It's very scalable with a simple API that uses put, get, delete, for example. One problem is you can't always query based on the content of the value because you're looking at the key. We also have the locker analogy as well, where keys are used to access blobs of data. We could use those to access video and images or voice. And the key uniquely identifies each of those records, and the value is simply an object. We've also got the graph data store as well, and that underlies technologies such as Twitter, if you use Twitter. It's very common in social networks, and it provides us with a very fast network search. The data is stored in nodes which have properties, and they're connected together. However, they don't always scale very well, and the queries can be very specialized. We also have document storage systems. For example, Azure Cosmos DB is one example. Here, data is stored in nested formats, and the document is stored as a single blob of data. You can use JSON or XML formats to store the document. Similar to object stores in many ways, it doesn't shred the data into tables, but it can have subtrees and attributes of documents. It's very fast growing, and the companies which deal in document databases tend to be quite fast growing in terms of their revenue, such as Mongo and Couchbase. We also have database availability as well. How available is our database? So we're going to cover some of these concepts as well. One important one is database availability, where the database and the application is available in scheduled periods. We have to think about getting the application having good uptime and what happens if the database becomes unavailable. Businesses expect continuous operation, where the system is available all the time and there's no scheduled outages. They're also looking for continuous availability as well, where the data is always available and we do maintenance without shutting down the system. When we build big data systems, we have the CAP theorem, where we think about the consistency, availability, and partition tolerance of the system. A shared data system has two, so basically pick two, and you have to sacrifice one of those. Here's an example of some of the databases associated with that. So when we think about database, we have to think about, are we looking at ACID or base? This helps us to choose which database underlies our business intelligence and artificial intelligence systems. So we have ACID, where it's atomicity, it records all the data or none of it. Consistency, when we run the same queries, we should also get the same results. The transactions should be isolated and not impact each other. We also care about what happens when the database has a failure. When we build big data systems, we're thinking about base. It's basically available where it seems to work all the time. We're not expecting always to have consistent results to every single query because the system will catch up with itself, and that's known as eventual consistency. We also have to think about scalability. Are we going to scale vertically, where we make the servers more powerful? Or are we going to scale horizontally, where we add in more computers more frequently? We can also think about how we partition the data and how we can share it between different nodes. There are plenty of different technologies where we can partition the data in order to try and get really fast performance. Azure Synapse Analytics is one example. We can also think about replication as well. This is a very common way of trying to solve reporting problems when people replicate the database from one to the other. And this is becoming a real problem for businesses because as they generate more data, then the amount of data makes it difficult for organizations to continue to use a single system to process all of their data. We have to think about the distributing of the tasks among many processors, and that's fundamentally the big data problem. When we start to look at NoSQL solutions to solve big data problems, we can think about different ways to handle and manage our big data sources. We can move data to reads and allow the database to distribute queries evenly to the data nodes. That helps us to manage the data and keep the systems running well. Because after all, databases fail. We have Murphy's Law, anything that can go wrong will go wrong. There's human error, I'm sure you see that a lot. We can also have to deal with network error or even hardware failure. We mentioned security earlier, and that's another potential issue as well. We've also got to consider terminology. Big data is not the same as NoSQL. NoSQL can deal with more than simply big data sets. And big data problems are, however, a primary use case for NoSQL, and that's why we think about these things. We can also think about whether we should have one database or many databases. Now, one database is really easy to understand. Set up and configure and off it goes, but it doesn't always scale well. We can end up with linear scalable architectures, which provide a constant rate of additional performance as the number of processes increases. We've got non-scalable systems which can reach a plateau of performance. So we add in new processors, but it doesn't add incremental performance value. Some systems continue to add performance as more nodes are added to the system. Performance can be a measure of read operations, write operations, or transformations. Systems can be considered linearly scalable if the performance curve doesn't flatten out. We can scale reads, writes, totals, or we could scale independent transformations as well. This is really important for big data processes, but the ability to read and write single records isn't only a concern of many business problems. We must be able to effectively perform queries on our data. Now, linear scalability will allow us to get a consistent amount of performance as we add additional processors to the cluster. A key thing when we think about choosing a NoSQL solution is how does it perform in terms of scalability and expressivity. Expressivity is the ability to perform really fine-grained queries on individual elements of your dataset. These are often difficult to quantify, but you can start to do this by using proof of concept, which is the best way forward. So if you take two extreme cases, such as a key value store or a document store, let's assume for a moment that both systems have got similar linear scalability rules that meet business growth needs. Which one is the right one to choose? The answer lies in how you want to retrieve the data from each of those systems. If you only need to store images and use a URL to specify an image, then a key value store is fine. If you need to be able to store items and query a specific subset of items based on properties, then a key value store isn't a good match, since the value portion of the key is opaque to many queries. So you could have a document store that could index dates, amounts, and item descriptions. His big data problems are listed here. We want to work out whether we want to do read mostly, and the read mostly data is the most common classification. It includes data that's created once and then rarely altered, such as data warehouse applications, images, videos, event logging, that kind of thing. We can also think about log events. When operational events occur in the business, you can record that to a log file and include a timestamp so you know when the event has occurred. Log events include activities such as a web page click, for example. NoSQL systems are changing companies' thoughts on log data as the cost to store it starts to really decrease, and to analyze it is becoming way more affordable, so marketing departments tend to like it. Business intelligence operational data isn't just trends in web traffic, however. It can integrate data from different sources, such as network monitoring systems. So you can detect problems before they impact your customers. And that's where your AI starts to come in, where you use it to try and predict where the problems might come in next. So how can we convey the patterns in the data when we find them? Let's have a look at data visualization, which is not just internal data, but it can also include external data sources as well. It helps us to understand data that's challenging to understand on its own. Computers are anti-Faraday machines in some ways. The physicist Faraday said that he couldn't understand anything until he could count it. Well, computers count everything and understand nothing. Why is data visualization important? We have a flood of data, but it's not always wisdom. So Ptolemy Soter was the first king of Egypt, and he was the founder of the Alexandrian Museum. He patronized the museum, and he studied geometry there under Euclid. Now, Ptolemy Soter was the first king of Egypt. He found geometry hard, and one day asked Euclid if there wasn't an easier way to learn the material. And Euclid replied, in the real world, there are two kinds of roads. One road for the common people to travel on, and at the time, they were roads reserved for the king to travel on. In geometry, there's no royal roads to understanding. So that's why it's important. We're trying to give people that royal road to understanding the data. So it's important. We saw some mistakes earlier. George W. Bush, I know we poked a little fun at Bill Clinton earlier, so it's Bush's turn now. It's clearly a budget, he said. It has a lot of numbers on it, so he perhaps didn't understand what he was reading. And Lewis Carroll is the writer of Alice in Wonderland and Through the Looking Glass. He said there are three branches of arithmetic: ambition, distraction, uglification, and derision. And sometimes it can feel like that to business users when they don't understand the data very well. Data can help us to grasp patterns and outliers. We can see them as general purpose techniques for understanding data and tools to help us to understand particular information types and business purposes. Data visualization is about storytelling, going from the data to the facts, and data visualization can be used in a variety of different ways. Networks allow us to have unprecedented access to data that we never had before. It allows us to think creatively. And as we add in more IoT sensors, we'll also have the network of things, not just the Internet of Things, where we put IoT data together with everything else. So we're going to have good visual data literacy. Data, as we know, is not always correct. Here we have an example of the NHS recording 20,000 pregnant men, and the data systems have to capture the data more accurately than that. They also found that 3,000 young people aged between 0 and 19 were attending geriatric services. So obviously that's incorrect. So we need to visualize the data to help us to understand it and capture mistakes like that before it reaches the headlines. Visualizations require accurate and matched data, and we can't assume that good visualization will make up for bad data. The data is wrong, the data is wrong. Because business intelligence and artificial intelligence is all about the people first. The enterprise needs to be served by people, enabled by technology. Data means that it can be flexible and we can model it better, and it can deliver powerful results. When we deal with data for business intelligence and AI, we need mission-critical confidence. We need storage with high performance to enable our business to run with our data further, forward, and faster. We need to just not use business intelligence, but we need to make our businesses intelligent as well by empowering them with the data. Now, infographics are focused on clarification rather than data visualization. Infographics is where your mind is made up for you. It takes existing data and repackages it so that it's easier for people to understand it. It can profoundly express ideas in ways that are very creative. It simplifies the message. Data visualization, on the other hand, gives us real rules around presentation. It helps us to understand the data and ask questions of it, whereas as an infographic does that for us, it does the thinking for us. Here's an example of an infographic using the Muppets. It's one of my favourite visualizations. It's just that infographic. It always makes me smile. So how could we group the Muppets together so that it's simplified for us. So this is an infographic created by Nathan Yao of Flowing Data. If you haven't checked out his website, I recommend you do. So we have to think about the aim of the visualization being displayed. If it's recycling the data to simplify the message for you, then it's infographics. If it's presenting you with the data to help you make up your own mind, then it's data visualization. Often the boundaries are not clear, and that's where a knowledge of statistics is really crucial when we work with data to help us to evaluate the subjectivity of the message and help the data consumer to help find alternative interpretations. Here's an example very well known from Anscombe Quartet, and in each of these visualizations, the property mean value is identical, as is the variance, the mean of y, the variance of y, and the correlation between x and y in each case. The linear regression line is also identical. What's different is the data itself. The top left-hand side, the data is set together in a more normal distribution. In the top right-hand side, it's not distributed normally and it's not linear. In the bottom left, we've got linear data where the outlier exerts an influence. Bottom right, the data is non-linear, but the outlier is enough to produce a high correlation coefficient. So by visualizing the data, we can understand the accuracy of it better. So I'm just about to wrap up shortly, so if you've got any questions, please remember to ask away. I just want to give you a few examples why data is so important for businesses and organizations. And then if you've got any questions, please feel free to ask. You may not know what this is. In 1986, the Challenger shuttle disintegrated in space. But why did that happen? Many people assume it was because of poorly functioning O-rings on the side of the booster rocket. The O-rings froze, but those O-rings didn't send the Challenger into space. People did. People made that decision to do it. And people drew the most critical information from two very simple charts showed by an overhead projector. The graphs display tiny pictures of each shuttle booster, lined up in chronological order, showing launch temperatures and any potential O-ring damage. This included the data showing the impact of the effect of the temperature on the O-rings, so it wasn't clear. Here's the original data visualization, and what we can't see here is the impact of temperature on the O-rings, which were helping to hold the Challenger and the booster rocket together. A gentleman called Edward Tufte retook the same data and we visualized it. And what we see here on the left-hand side, on the y-axis, is the number of damaged O-rings per launch. And the x-axis, we see the temperature. So the story is, the lower the temperature, the more likely we see damage to the O-rings. Now, when the Challenger exploded, we know that the O-rings froze, and that was the problem. So given that, why don't we just show tables? I'm sorry, that's not very clear. What we see here is that tables aren't always very clear or easy to read. But when we start to visualize the data, we can start to see it a bit better. We lose the detail, but we do gain a better appreciation of the patterns in the data. The table and the graph complement each other, but they don't necessarily replace one another. So with that, sometimes a picture is worth 1,000 words. So the data here shows how we could buy 3 eggs or 2 apples with a $100 billion note. This was in Zimbabwe during the hyperinflation process that happened a few years ago. So sometimes when we are telling a story, pictures can really help us in order to understand that. So the summary here that we have is that there are many different frameworks for storing our data. And those fundamentally support artificial intelligence and business intelligence systems. It may not be a popular message, but if the data is not good quality and not correct, that will impact everything else. It will fundamentally impact the business to make bad decisions, as we saw with the Challenger example. We also had a look at artificial intelligence in terms of what will happen next. So that's why cybersecurity is so important. And we also had a look at some examples for visualizing the data and asking really good questions of the data. So just to wrap up, my name is Jennifer Stirrup. It's been my pleasure to be with you here today discussing big data, artificial intelligence, business intelligence, and data visualization. I hope that's given you a good overview of what businesses need to think about when they start to look at their data, and hopefully you can help businesses to make their data work with their as they move forward in their success. So with that, I'm going to hand over to the moderator to see if there's any questions. I'm sorry, I can't see my chat window. I'm just going to stop sharing so I can see chat.
Thanks a lot. Thanks a lot, Jen. It was really a great session. We had means I guess means students had gained a lot of insights. Means lots of examples are present in this session. So means it's a really great session. So there are few questions in the chat box. Harshit has is asking means how do students at universities start this journey in becoming an AI business leader? What skills do they need?
So what skills you need is a lot of soft skills, great communication, and you can use data visualization to help you to communicate. So soft skills are always important. So if you can do some sort of um, a management course would probably be quite helpful. What I'd suggest as well is if you can get some hands-on practice, you can do that by supporting and helping charities with their data. Often charities are not able to afford high quality um, people to look after their data. So if you find that you can support some charity through in their journey with their data, perhaps as a volunteer, then you can really help them. And it also helps you by helping you to get great skills. In the United Kingdom and in the United States, there's a charity called DataKind. There are other charities as well. But what DataKinds do is they offer data science skills to charities that need it. So if there's any data science or AI charities, you can join those as a university student and get some great practice. It's also great for networking with your peers because I think networking is so important. So if you can engage on LinkedIn or Twitter or write a blog, anything like that, put yourself out there a little bit and show your passion by blogging, for example, about AI and topics you're interested in. As students, that will really make you stand out. I sometimes help organisations to hire other people. So I attend interviews and I interview potential candidates. And when I'm reviewing CVs, what I'm looking for is to see, are they self-motivated? And are they sharing knowledge and information? And how do they communicate? Writing a blog will really help you to do that. Now, you don't have to always write things that are very long. Sometimes if it's a longer article, you can split it up into different, a series, maybe of 5 posts. I bet you as part of your university course, you're probably writing essays and reading all the time. So perhaps you can take some of these course notes you've got and start to turn those into blog posts. It will help you to revise for exams, but it will also help you to share what you're learning. So if I'm looking at your CV, I can say, oh, I can read your blog posts. I can see that you are passionate, you're excited about this, you are proving that you know this stuff. And you're making yourself accessible as a leader by pushing yourself out there a bit. So hopefully that helps you to find ways to get yourself out there. and also help improve your knowledge and expertise at the same time. If you send me a LinkedIn message, I'd be happy to read any blog posts. I can put them and share them in LinkedIn. I put them in Twitter, so I'm happy to help you to do that.
Thanks a lot, Jen. There are a couple of questions more. How can we come to judge that the data collection method is relevant and reliable to the problem?
That's a great question. So I'm just going to read the questions again. Yes, so data collection, um, I think what you have to do is be very clear in what the business vision is. So I always tell businesses, look for your most valuable customer. Now, who is your customer and who's your most valuable ones? Now, that sounds like it should be a really easy question to answer, but it's actually really hard because customers don't always know who's generating the most profit for them, and they don't always see the secondary influence that they can have on other customers, you know? So if the data is all about the customer and trying to help you to understand better if the customer is profitable, I would definitely keep that. I think if you're not sure if the data is important or not, you can hang on to it, but maybe store it in cheap blob storage. But to do that, I'd really recommend that you have a data dictionary so that you record and understand the data. I was working for one organization that helps them to hire a junior data scientist who was just out of university. And one of the first jobs I gave her was to document all the data sources. Now, I'm sure she wasn't very happy about it because it doesn't sound very interesting. But by the end of the 3 months, she knew more about the data than anybody else. And she went from being a junior to being a really crucial team member because she knew more. She was the touchstone and she documented everything. Because at first she said, I've got all these columns of data, nobody knows what they mean. What are these codes? And I said, well, you have to go and ask people. Somebody somewhere will know. Go and ask an older team member who's been there for a longer period of time. They probably know this stuff and they've probably just never shared it. Go and ask them. And it was a good way of helping her to become very engaged and meet other people in the organisation and to become more sociable. Because when you first join a new company, you don't know anybody and it's hard to make friends. But by giving her that task, it really meant she could go round with an activity and ask people for help. And it really helped her to get to know tons of people. So I really recommend, if you're not sure about data collection, data dictionary, data glossaries maybe sound really boring, but you can use those for your own success because you will know that data inside out and you will be the most popular person in the office when it comes to the reports. And when you can understand the reports, it puts you in front of the business leaders. So that means you go from being a junior to suddenly talking to the people that are running the business. They want their data and they're going to come after you to ask for it and to understand it better. So your visibility in the organisation becomes quite high. And it also means when they're thinking about, promoting people, that you're in their minds because you know the data. You speak to the business leaders, so you're setting yourself up for career success. So you can use what seems like a boring task for your own advantage. I hope that helps.
Yeah, it's really a great thing you had explained. So there is another question. Your opinion on the much hyped digital transformation. Is it just a hype or is there true value to be extracted?
I think that um, I don't think it's just hype, although I think it's a buzzword. I'm not sure I like the term digital transformation. I actually prefer the term continuous transformation because every business should be trying to get better. The word digital makes it sound as if it's older in some way, it's aged. Everything's digital, so it's almost irrelevant in some ways. So businesses should always be asking themselves, how can we do better? It doesn't have to be digital to do that. So I think where I see the most value being extracted is where you put the customer front and centre. I also think there's great value to be understood in terms of optimizing processes. And normally, the evidence for a bad process is bad data somewhere. So digital data is the symptom for a much greater problem elsewhere. People find it really hard to change processes in a business. And sometimes if the process seems to work, they don't want to touch it. But there's always a cost somewhere. And where do you put that cost? Is it in having a bad process which nobody wants to touch? So I'll give you an example. One of my customers was looking at using artificial intelligence to use it for transcribing handwriting. They were transcribing forms and using AI cognitive services in order to do that. The thing is that the process of typing in all of those forms into a database took forever. And the business were getting increasingly busy, but they had this pressure point. So we automated a lot of the handwriting analysis, so it went into text format. And it did not replace the people who were who were doing the typing of the transcriptions into the database. What happened was, however, that the job changed. Instead of getting a form, they got a form and the transcribed version. So it made them faster at transcribing because we're already being given something that was 80% correct, not always 100%. They could fix it and then move on faster with their day. So there is value in optimizing these processes with technology. You can measure it in terms of productivity and cost sometimes. So if somebody takes 48 hours to do something, but then you've optimized it and it takes less than a day, it means you can make more of their human skills by doing something else. So I think there's value, and calling it continuous or digital transformation just means it gets the attention of the leaders usually, but every business should be looking to do that all the time. I hope that helps.
Yeah. There is another question. Recently, he had been came across an article that AI is nowhere, where near bankers when it comes to making some of the crucial decisions. Do you see if there will be a dramatic change regarding this in the near future?
So it just broke up for me at the very start of that. Could you repeat that just for a second? Sorry.
Yeah. So means
Sorry.
he had been came across an article that AI is nowhere near bankers when it comes to making some of the crucial decisions. So do you see if there will be a dramatic change regarding this in the near future?
I don't think there'll be a dramatic change in that aspect. I think AI eventually will be used more to automate and make it easier for people to make decisions. I think sometimes I see organisations like Microsoft firing all of their journalists and replacing them with search bots. I think that was a terrible decision because I think you're putting something into the hands of technology which requires real creativity rather than a search bot. And if you've ever used Bing, you know it's not as good as Google, for example, in giving you good search results back. So when I see something like that, I think sometimes people are misplaced in terms of their efforts in allowing technology to make decisions for them. I think it can be made easier for people to make decisions by presenting them with the right information. If you take x-rays of cancer, for example, the AI algorithms could look at 1,000 x-rays and dismiss 800 of them as being not relevant because there's no tumour there. But the other 200 could be given to a specialist to analyse, making them more productive, but not and making their job a bit easier, one would hope. But I'm not sure that there's always going to be that huge dramatic change in replacing managers. I think many organisations are still struggling to get their hands on their data properly. I mentioned earlier the data democracy. Many organisations just aren't there. So I hope that helps, but I don't think there'll be. I think what will happen is people will try it, they'll see that it doesn't work, and then or doesn't work as well as they'd hoped. They've got into the hype. There's a lot of hype. I mean, you're right about that. There's tons of hype. But when people try things, they get realistic. So they try, they fail, and then they try again. And I think that's probably where we will go. For example, if Microsoft rehire those journalists, they're not going to release a press release to say that they got it wrong. They're just going to hire more journalists back again, rather than say actually the technology didn't work quite as well as we'd hoped.
So I guess that's all the questions we had. We can thanks a lot once again. Thanks a lot, Jen, for conducting this session. And yeah, we can wrap up the session now, I guess.
Thank you so much. Thank you all for having me and thank you for joining me. It's been lovely to get the invite and thank you so much for reaching out. Thank you. I hope you have a great day.
Thank you so much.
Thank you.